Pictures will perform multiple transformations to a figure on a coordinate grid. So what we're going to see today is now we're going to have these figures, and we're not just going to be rotating it. We're not just going to be reflecting it. We're not just going to be translating it. We're not just going to be dilating it. We may be reflecting it, then rotating it. We may be translating it, then reflecting it. We may be translating it, then dilating it. Or any of these other combinations do multiple transformations to our figure. So with our first one, we're told that it's translated 4 units to the right. So we're going to start with our original points, translated 4 units to the right. Got to get my units down over there. We have got -3, +1. For B, I've got -4, -4. And for C, I have 1, -2. So I need to translate this 4 units to the right. How does a translation of 4 units to the right change our coordinates? Sammy? It's only going to change the x, and how is it going to change the x?
It's going to move wherever the coordinates are, 4 units to the right.
And 4 units to the right means how does it change these numbers? 4 units to the right. How does that change the numbers? Yeah, add 4 because moving to the right is in the positive direction. So we're adding 4 to all of our x values. 1, 1, and 4 plus -4 gives me 0, -4, and 5, -2. Now this is fantastic. That means that we now have our points A prime, B prime, and C prime, but it tells us that the figure is then reflected across the y-axis. So we were sitting with A prime, B prime, and C prime, so we have all of these points. We're just going to copy over here. And we're told that they are reflected across the y-axis. So what do I need to do to take these points and now reflect them across the y-axis? How does that change my coordinates? And I see Edgar looking over at his do now. As a reminder, and that's absolutely what you should be doing, is if you can't remember them, you just recreated those rules so you could use them as much as you wanted. Edgar, how does it change it? Yeah, change the sign of the y, the x stays the same. So the x's are all going to stay the same, 1, 0, 5. And the sign of the y is going to change. This becomes -1. -4 becomes +4. -2 becomes +2. This is our new figure. It says to graph the new figure. So 1, -1. This is A prime prime. This is after both transformations. 0, 4. This is B prime prime. And 5, 2 over 5, 2. This is C prime prime. So we should be changing the x-coordinate sign. So we should have -1. 0 doesn't change. -5. And so the y stays the same. 1, -4, -2. And that's going to give us our reflected across the y-axis. So we can now graph these points. -1, 1. This is our A prime prime. That's after our second transformation. 0, -4. 0, -4. That's our B prime prime. That's after the second transformation. And the -5, -2. That's our C prime prime after our second transformation. So we can see here that this figure is still the same as the original figure. It just looks like it's kind of been turned around and moved around a little bit, but it's still the same figure. It's still congruent. And that's actually going to be a part of our definition of congruence when we get to it, is that a congruent figure is really just a shape that's been turned, flipped, or moved, and nothing else has changed to it. All right. The second example. It says the figure is rotated 90 degrees clockwise. Write the original points and the new points. So looking at our original points, we have 0, 5. C is 2, 2. And B is negative 1, negative 2. So we want to rotate this 90 degrees clockwise. How does that change my coordinates? I want to rotate this 90 degrees clockwise. How does this change my coordinates? If you don't remember, you just created this rule. Go back to what you wrote down when you created this rule. Jasmine. So she's telling me to switch them around. Oops. She tells me to switch them around. And then she says that if it's going clockwise, this one is going to change its sign. So that means those all become those y's over here. That means this 0 becomes a negative, the opposite of 0. Well, that's the same. Negative 1 becomes the opposite of negative 1, which is positive 1. This 2 should become the opposite of 2, which I need to add over here is a negative 2. Over here, these should all keep the same sign. So 5, this one should stay negative 2, and this one should stay positive 2. So these are our new points after the rotation. But then it's told us that the figure is dilated using a scale factor of 2. So we take our points. This is what it was. And then we dilate it. How is that dilation with a scale factor of 2 going to change my coordinates? How is that dilation using a scale factor of 2 going to change my coordinates? Kali. Everything gets multiplied by 2. Is this going to make my figure bigger or smaller? Bigger. All right. So times 2 is 10. Times 2 is 0. Negative 4. 2. 4. And negative 4. So let's go ahead and graph the final figure. I have 10, 0, that's way over here. A prime prime after 2 transformations. B prime prime after the 2 transformations. Negative 4, positive 2. And C prime prime 4, negative 4. And then when we look at the figure and the original figure, does the figure look like it's the same quote-unquote shape? Does this look like a similar figure? Yeah, it's similar. It looks like it's just been turned and then made bigger. And that's exactly what we said it should be doing. Rotated and then dilated. Made bigger in this particular case. Questions about that? Yes, sir. So if we need the visual, like I can literally like turn it and rotate it. It's like, oh hey, that's what that red thing looked like. All right. Jaquan.
Whenever they tell you, you don't know like what, because they tell you 180 degrees, they don't tell you like how many clockwise and counterclockwise to rotate 180 degrees. So you just, what do you do?
Yep, so Jaquan is asking a question about 180 degree rotations. Is there a different rule for a clockwise 180 and a counterclockwise 180? No, so does it matter?
No, so you just,
Yeah, so if it doesn't tell you, just like whatever.
it's easy.
I don't need that info anyway. All right, a figure has the following coordinates. It's translated 2 units to the left and then rotated 180 degrees clockwise. So the first transformation is the translation 2 units left. How does that affect my coordinates? Translated 2 units to the left. Crescent, how does that affect my coordinates? Add -2 to the x. So x left goes us in the negative direction on the x. So I'm going to add a -2 to all of my x's. This is my first translation, my transformation here. -5, 2, -3, 3, and there's no transformation in the y direction at this point, so we're all going to leave this the same. Aaliyah. Why is it not in the y direction? So if we think about how that's changing our coordinates, if we look over here at one of these, if we're moving it left or right, all that's really changing is our x coordinate. If it was going to change our y coordinate, it would have to be moving up and down. And so it doesn't tell us about any movement up and down here. So looking back over here, so this is after our first transformation. That's all taken care of. Then it's rotated 180 degrees clockwise. How does that change my coordinates? How does a 180 degree rotation change my coordinates? Tarak, how does a 180 degree rotation change my coordinates? Look back at your do now. You just created these rules. Switches the signs, and that's all it does. So -5 becomes a +5, 2 becomes a -2, -3 becomes a +3, -3 becomes or +3 becomes a -3, and so on, and so on, and so on, and so on. And this would be our new figure. All right, last one. Now, it seems like it's the same thing. That's why we're going to change it. Please don't make the same mistake that somebody made in a previous class and have me ask a question in 2 minutes and you still be working with the original problem. All right, we're going to change this to it is reflected over the x-axis and then rotated 90 degrees clockwise. So make that change. I just want us to get one more under our belts. Practice together. A figure has the following coordinates. It is reflected over the x-axis and then rotated 90 degrees clockwise. So, the first transformation is a reflection over the x-axis. How does that change my coordinates? A reflection over the x-axis. How does that change my coordinates? Jesus, how does a reflection over the x-axis change my coordinates? Yeah, switch the signs of the y, because we're just staying on the same left-right field, but we're just flipping it over that y-axis, up and down. All right, so that means our y, which is our up and down, this is going to switch signs. This becomes -3 to -2. This becomes a -4, +4, x stays the same. -1 becomes +1, and 8 becomes -8, +5. All right, so it's reflected over the x-axis, And then it's rotated 90 degrees clockwise. I think we've already talked about the rule for 90 degrees clockwise today. How does that change our coordinates? Catherine. Won't it change to the original ones? Well, think about it. What is it going to do to these center points? What's our rule there? Okay. The X and the Y switch. And what else? What else? Go back to your notes. One of them changes signs. Which one? Giselle. Both of them, this is a 90-degree clockwise turn. Yeah, so this one should be changing signs. So I'm going to go back through and I'm going to change the signs of all of these. Should become a positive 3. This will become a negative 4, a positive 1, and a negative 5. That's going to make a big difference in your figure if you do not have those switching signs properly. Those 90-degree rotations, clockwise and counterclockwise, are the most difficult to get straight. Make sure that you are super focused on your work when you're doing 90-degree rotations.